Welcome to our exploration of one of the universe's most intriguing questions. Does extraterrestrial life exist? Today, we delve into the depths of this mystery, examining various theories and scientific inquiries that have captivated our imagination for centuries. Extraterrestrial life encompasses beings not native to Earth, encompassing all life forms outside our planet. This includes entities ranging from virus-like to plant-like organisms. Some theories extend to entities with human-like complexity or even greater, often referred to as aliens. Despite this, concrete evidence of such life remains elusive. The Fermi Paradox, named after physicist Enrico Fermi in 1950, grapples with this mystery. Fermi proposed the existence of advanced extraterrestrial civilizations capable of surviving millions of years and colonizing galaxies through intergalactic and interstellar travel. He speculated this might have already occurred, yet our search for extraterrestrial life has yielded no results, presenting a paradox. This paradox leads to questioning the rarity of life's origin on Earth. The universe's vast age and numerous stars suggest the likelihood of life beyond Earth. However, if Earth's life genesis is a unique event, it supports the rare Earth hypothesis, which posits that life, especially complex life, is exceptionally rare in the universe. The prevailing theory suggests Earth doesn't hold a unique position in our solar system, and there may be other technologically advanced civilizations in our galaxy. The Milky Way spans about 100,000 light-years in diameter. Considering sublight travel, traversing such a distance could take up to 10 million years. Given the galaxy's estimated age of around 10 billion years, if a civilization within the Milky Way had the capability for interstellar colonization, it could theoretically colonize the entire galaxy in just a few million years. However, the Milky Way is much older than the minimum 20 million years required for this process, implying that extraterrestrial life should exist relatively close to Earth. Yet to date, there is no definitive evidence of extraterrestrial life, leading to a paradox. If extraterrestrials exist, why have they not been encountered? This conundrum is closely related to the Drake equation, which attempts to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way. However, most parameters of the Drake equation remain unknown, limiting its usefulness in resolving this paradox. Additionally, the Drake equation focuses solely on the Milky Way, a barred spiral galaxy, a type which constitutes about 2/3 of the known galaxies in the universe. Considering the estimated 100 billion galaxies similar to the Milky Way, the final figure derived from the Drake equation would need to be significantly adjusted to reflect the broader scope of the universe. Expanding the Drake equation to encompass the entire universe significantly increases the estimated number of potential civilizations. However, this calculation remains imprecise due to limited knowledge about other galaxies. The Drake equation not only estimates the theoretical number of civilizations, but also considers the feasibility of establishing contact with them. The nearest galaxy, the Andromeda Nebula, is 2.5 million light-years away, making practical contact with any civilization there, or in further galaxies, highly improbable. One theory suggests that multicellular life in space is exceedingly rare. This rarity is attributed to the scarcity of Earth-like planets, as many unlikely events coincided to enable life on Earth. Factors contributing to Earth's habitability, such as the presence of the Moon and Earth's position in the solar system, are considered rare coincidences. In this view, the parameters of the Drake equation are set such that our galaxy hosts only our civilization, resolving the Fermi paradox by negating one of its basic assumptions. This hypothesis is persuasive to many scientists. However, the increasing discovery of exoplanets challenges this view, as it suggests Earth-like planets may indeed exist. This ongoing discovery supports the belief of some scientists that Earth-like planets are not as rare as previously thought, keeping the door open to the possibility of extraterrestrial life and interstellar colonization. The Fermi Paradox hinges on the existence of civilizations capable of interstellar colonization. However, such a premise may be fundamentally flawed due to the immense distances between stars. For instance, traveling from the Sun to Proxima Centauri, our nearest star, would take several years even at the speed of light, which, according to current understanding, cannot be exceeded. This limitation raises several questions: whether it's feasible for a civilization to reach other star systems and whether such an endeavor would be beneficial. Additionally, it prompts consideration of the acceptable time delay in communication between civilizations from different star systems to maintain cohesion. Stephen Hawking posited that life beyond Earth is likely and that human-like intelligence is possible elsewhere. However, he speculated that such intelligence might eventually reach a limit, leading to self-destruction through means such as genetically modified viruses, nuclear wars, or uncontrollable greenhouse effect. Two theories further explore the challenges of extraterrestrial life. The Berserker theory, inspired by Fred Saberhagen's Berserker saga, suggests that aliens might send out artificial probes to destroy other civilizations preemptively, eliminating potential threats. The Dark Forest theory, although not mentioned in the original script, complements this by proposing that civilizations remain silent and hidden, like hunters in a dark forest, to avoid detection and potential annihilation by more advanced civilizations. These theories reflect the complexities and potential dangers of interstellar interaction and the survival of civilizations in the vast expanse of space. The theory of extraterrestrial civilizations self-eliminating to enable unimpeded expansion into space is subject to varied interpretations. Complementing this, the Dark Forest theory, inspired by Lou Sixon's trilogy, The Dark Forest, suggests that extraterrestrial civilizations exist, but remain hidden and inconspicuous to avoid detection by potential adversaries. This strategy, akin to biological camouflage, is thought to minimize the risk of becoming prey in what is metaphorically described as a dark forest universe, where various predators vie for the most effective concealment. From an astrophysical perspective, gamma-ray bursts, the most energetic events in the universe, are capable of causing mass extinctions on planets within their radiation cones, even light years away. These bursts could have hindered the evolution of complex life forms in galaxies, especially during the universe's first 5 billion years, due to intense gamma-ray activity. Astrophysicist J. Richard Gott challenges the notion of galaxy-wide colonization. He argues that, if such widespread civilizations existed, it would be improbable for life to have originated on a relatively young and small planet like Earth, which would not have been colonized at that time. The Great Filter concept synthesizes some of these arguments. It proposes the existence of a sort of filter that a civilization must pass through to reach a certain level of advancement. This filter could represent a series of challenging steps in the development of life, from the emergence of simple life forms to the development of advanced civilizations capable of interstellar communication or travel. The Great Filter concept serves as a framework to understand why, despite the vastness of the universe, evidence of extraterrestrial civilizations remains elusive. The Great Filter concept posits a formidable challenge or hurdle that makes attaining a high level of civilization exceptionally difficult. One theory within this concept suggests that high intelligence is a rare evolutionary outcome, potentially making humans the only life form to have surpassed this filter to date. Alternatively, another theory proposes that the development of civilizations inherently leads to self-destructive outcomes, implying that other civilizations might have failed to cross this filter, leaving humanity yet to face and overcome it. Historical philosophical approaches to extraterrestrial life date back to antiquity. For example, Plutarch's work Das Mondgesicht includes speculations about non-earthly life forms. However, these early texts largely drew on mythology, not attempting to formulate theories about extraterrestrial life based on rational arguments. Astrobiology also grapples with the absence of a universally accepted definition of life. Despite numerous attempts, no definition has fully encapsulated the concept, leading to the suggestion that there might not be a clear demarcation between living and non-living entities. Furthermore, even if life akin to that on Earth exists elsewhere, it remains an open question whether such life originated independently or was somehow disseminated from Earth. Regarding the existence of aliens, our perspective has dramatically shifted in just the last century. 100 years ago, our understanding of even our solar system was limited, let alone our comprehension of planets beyond it. This historical context illustrates the rapid advancement in our astronomical knowledge and the evolving nature of our search for extraterrestrial life. Initially, while telescopes allowed us to observe planets, we lacked detailed knowledge about their surfaces and whether they hosted human-like beings or other forms of life. This changed in the 1960s with the advent of space probes, which revealed that our neighboring planets were uninhabited. Efforts to find even the most minimal traces of life, such as bacteria, lichens, or mosses, have been unsuccessful to date. Our capabilities have since expanded, and we now have telescopes that can detect planets beyond our solar system. Several exoplanets have been discovered in the vicinity of Earth, but their potential to support life remains uncertain. No definitive signals of extraterrestrial life have been received. In 1960, astronomer Frank Drake began the quest for extraterrestrial signals using a radio telescope to explore two nearby sun-like star systems. This endeavor later evolved into the international SETI Search for Extraterrestrial Intelligence project. For over 60 years, researchers have been scanning the cosmos, hoping to detect any sign of life, civilization, or technological activity. Although a few unexplained signals have been picked up, none have been conclusively identified as a technosignature of extraterrestrial origin. Facing the possibility that we might be alone in the vastness of space is a sobering thought. Jill Tarter, co-founder of the SETI Institute in California, however, remains optimistic. She believes our search has not been extensive enough. Comparing space to an ocean, Tarter suggests that in the first 50 years of searching, we have only explored an area equivalent to a small glass of water, implying that there is still much more to investigate before concluding our solitude in the universe. Technological advancements in recent years have greatly expanded our capacity to explore space, likened by a SETI researcher to growing from examining a glass of water to a bathtub in the last decade. However, this is still a minuscule fraction of the vast cosmos, making it premature to declare that aliens do not exist, especially considering the lack of conclusive findings so far. Our timing in the universe's history might be a factor in our solitary experience. The universe, approximately 13.4 billion years old, saw its first galaxies about 200 million years after the Big Bang. Life on Earth took 3.8 billion years to evolve to its current state. It's plausible that other life forms existed in the cosmos before our technologically advanced civilization emerged. These beings might have sent signals to Earth during our Stone Age, going unnoticed. Meanwhile, these civilizations could have vanished or stopped their search, possibly believing themselves to be alone in the universe's immensity. It's also conceivable that numerous other life forms exist in space, potentially at different stages of development. They might not be capable of or interested in detecting our signals, focusing instead on their own existential journeys. The sheer scale of cosmic distances presents a formidable barrier to contact. The concept of sending a radio signal or a probe into space seems straightforward, but the immense distances make it a daunting task for our current technological capabilities. The vastness of space, coupled with the limitations of our technology, underscores the challenges we face in making contact with extraterrestrial life, if it exists. The Voyager probes, launched over 30 years ago, took decades to reach the edge of our solar system. To encounter the next stars and planets in interstellar space, it could take several hundred to thousands of years. The nearest star system, Alpha Centauri, is just over 4 light-years away. While this distance might seem manageable, It's important to remember that light, traveling at 300,000 kilometers per second, takes 4 years to cover this distance. In contrast, our spacecraft, propelled by vast amounts of fuel, can only achieve a maximum velocity of 28,900 kilometers per hour. This speed is significantly slower compared to the velocity of light, making interstellar travel extraordinarily time-consuming. With current technology, a journey to Alpha Centauri would take about 75,000 years. Radio signals, which travel at the speed of light, have created a detectable sphere of human presence about 60 light-years in radius. Within this sphere are several star systems and likely dozens of planets, yet no responses to our signals have been received. If a distant civilization 60 light-years away were to receive our signal now, it would take another 60 years for their response to reach us. Thus, it's possible that extraterrestrials received a message from Earth decades ago, but their reply has not yet arrived. Regarding alien contact, there are numerous speculative stories. Some suggest that aliens have attempted to contact us, but were hindered by Earth's political complexities. Others believe such contacts have occurred, but are kept secret from the public. Many UFO sightings around the world and near the International Space Station, ISS, are often cited as evidence of alien existence. These sightings imply that if extraterrestrials are observing us, they have chosen not to make active contact. According to some scientists and UFO enthusiasts, there might be compelling reasons for this apparent reluctance to engage with humanity. For a highly advanced extraterrestrial species, humanity might appear primitive. Our exploration of Earth, alongside significant social issues, wars, and environmental degradation, may not paint an attractive picture of our civilization. In the 1960s, Russian researcher Nikolai Kardashev developed a scale to measure a civilization's development level based on energy consumption and production methods. This scale, originally consisting of 3 levels, also considered factors like global peace, efficient and non-harmful resource utilization, and high social standards. Presently, humans rank at about 0.6 on this scale, with level 1 being achievable only if we successfully address our environmental issues and social conflicts. Civilizations capable of interstellar travel with UFOs might have surpassed level 2.5 on the Kardashev scale. To such advanced beings, humans could seem akin to semi-wild animals. They might observe us, but avoid contact as a precaution, given our unpredictability. From their perspective, our International Space Station, ISS, could appear as outdated as a 1960s oven, and they might be perplexed by our struggles with weightlessness in space and managing space debris. If these aliens observed Earth's attempts to colonize Mars due to fears of Earth's deteriorating condition, or saw figures like Jeff Bezos proposing to move heavy industry to the moon, they might simply dismiss these efforts as primitive and move on. In the realm of extraterrestrial life research, some scientists speculate that organic life is just one possible form of life. It's conceivable that alien life could exist in entirely different forms beyond our current understanding or detection capabilities. This possibility suggests that we might not have recognized alien life, even if we have already encountered it, due to its vastly different nature from life as we know it. The enigma of life's true nature remains unsolved. We understand that on Earth, simple, single-celled organisms evolved over billions of years into complex forms like dinosaurs and technologically advanced humans. However, our current definition of life is limited to biological criteria such as respiration, cell division, and metabolism. The possibility exists that life encompasses much more than these parameters. Various spiritual traditions and ancient religions suggest the existence of other life forms beyond the physical realm. Depending on the culture, these entities are referred to as gods, spirits, fairies, dwarves, or light beings. Some progressive researchers entertain the idea that biological life might be just a temporary phase, applicable to the entire planet with its flora, fauna and humans, or to individual beings. Throughout history, humans have contemplated the concept of an immortal soul that persists in another dimension after death. It raises the intriguing possibility that we might exist as souls in another part of the cosmos, engaging with other soul beings. Considering contact with extraterrestrial life, the longing for such an encounter is a widespread human desire. The prospect of meeting intelligent, benevolent beings from other worlds who are willing to share their knowledge and experiences is a fascinating and appealing notion. However, this aspiration comes with its own set of uncertainties and potential risks, prompting the question of whether it might be better, at least for now, to not make contact with other life forms outside our own planet. Despite Hollywood's portrayal of various scenarios, the reality of a first encounter with extraterrestrial life remains largely unexplored and potentially risky. We have been sending signals into space, along with capsules containing information about our civilization, our DNA, and our technological progress, naively hoping they will be intercepted by peaceful and sociable beings. However, the possibility that they might not be received by such benevolent entities cannot be overlooked. Russian astrophysicist Nikolai Kardashev believed that technical progress is linked with the overall evolution of a species. He theorized that unintelligent and aggressive species would likely destroy their own planets and fail to achieve the technological advancements necessary for space travel, including light or faster than light travel. According to Kardashev, only life forms that have transcended hatred, anger, and rage would be capable of harnessing sophisticated forms of energy and traversing the cosmos. If his theory holds true, any aliens capable of reaching Earth would be socially advanced and friendly. To date, we have discovered about 5,000 exoplanets, a certain percentage of which might theoretically harbor alien civilizations. However, despite our observations of these planets, no definitive signal or evidence of an active culture on any of them has been detected. Despite Hollywood's portrayal of various scenarios, the reality of a first encounter with extraterrestrial life remains largely unexplored and potentially risky. We have been sending signals into space, along with capsules containing information about our civilization, our DNA, and our technological progress, naively hoping they will be intercepted by peaceful and sociable beings. However, the possibility that they might not be received by such benevolent entities cannot be overlooked. Russian astrophysicist Nikolai Kardashev believed that technical progress is linked with the overall evolution of a species. He theorized that unintelligent and aggressive species would likely destroy their own planets and fail to achieve the technological advancements necessary for space travel, including light or faster than light travel. According to Kardashev, only life forms that have transcended hatred, anger, and rage would be capable of harnessing sophisticated forms of energy and traversing the cosmos. If his theory holds true, any aliens capable of reaching Earth would be socially advanced and friendly. To date, we have discovered about 5,000 exoplanets, a certain percentage of which might theoretically harbor alien civilizations. However, despite our observations of these planets, no definitive signal or evidence of an active culture on any of them has been detected. The signal in question initially seemed to originate directly from the Proxima Centauri system. This area is generally free from jamming signals typically emitted by terrestrial electrical systems, satellites, or space shuttles. The narrow beam of radio waves, detected at a frequency of 982.0 MHz, appeared only once and very briefly. A notable aspect of this signal was a typical shift in frequency, which is often observed when a planet is moving, leading to the speculation that it could be coming from a planet in the Proxima system. Viewers of our channel might recall that exoplanets in the Proxima Centauri system have been considered potential super-Earths. This information was well known in the astronomical community in 2019 when the signal was detected. Consequently, it was tempting to correlate these facts and hypothesize that the signal emanated from an extraterrestrial world. However, Despite the initial exclusion of interference sources, there are numerous factors that could lead to the misinterpretation of signals. To confirm scientific findings, they must undergo rigorous testing. In the case of space radio waves, a series of filters are employed to determine if the frequencies seemingly from space might actually resemble terrestrial signals or have been distorted by interference sources. These filters also examine all known natural cosmic signal sources, such as fast radio bursts from supernovas or neutron stars. Before releasing information publicly, scientists conduct multiple tests and have their findings reviewed by additional researchers. This rigorous process ensures the accuracy and reliability of any scientific discovery presented to the public. In this particular case, the standard procedure was followed to validate the signal's origin and significance. The integrity of a study within SETI search for extraterrestrial intelligence was compromised when unconfirmed findings were prematurely leaked to the tabloid press. SETI, established in 1960, comprises research groups worldwide that explore the radio range of the electromagnetic spectrum received from space. This range includes cosmic waves audible to the human ear. SETI scientists specifically search for technosignatures, which are signals that differ distinctly from natural origins and could indicate extraterrestrial civilizations. The foundations of radio astronomy were laid in 1931 by American physicist Carl Jansky, who identified the first discernible radio signals from space, eventually tracing them back to the Milky Way's center. SETI operates as a non-profit organization, receiving funding from NASA Hewlett-Packard and contributions from private individuals. In 2015, Russian billionaire Yuri Milner donated $100 million to initiate the Breakthrough Listen program, further bolstering the search for alien civilizations. The discovery of a signal from Proxima Centauri would have been a sensational development. Proxima Centauri, a red dwarf star, is part of a triple star system, including two Sun-like stars. Since the early 2000s, researchers have found evidence of exoplanets in this system located about 4.2 light-years away. One of these planets, Proxima Centauri b, was long considered a potential super-Earth. Slightly larger than our planet and situated in its star's habitable zone, this rocky planet might have an atmosphere and water. While it's still unknown if Earth-like planets in other solar systems harbor life, receiving a technosignal from such a planet would be a groundbreaking discovery. A technosignature, by definition, could only originate from an advanced civilization, making it a profound indicator of life beyond Earth. Potential sources for the mysterious signal detected in the Proxima Centauri system could include radio transmissions from technical equipment on a planet's surface or even space stations. Alongside Proxima b, another exoplanet was confirmed in this system in the same year the signal was received. Proxima c had long been speculated upon. Initially, there was a possibility it might be an Earth-like exoplanet. However, in 2019, it was established that Proxima c is likely a gas giant situated well outside the habitable zone of its star. Following the premature publication of the signal in The Guardian, SETI researchers sought to provide a more measured perspective in the respected Scientific American magazine. They acknowledged the need for further investigation. Meanwhile, AZTI researcher Sophia Sheik heightened interest by noting the signal, named BLC-1, Breakthrough Listen Candidate 1, was the most exciting discovery in the Breakthrough Listen project because it passed many filters, a rarity for such signals. Seth Shostak, head of SETI's Breakthrough Listen program, clarified that while the signal is non-terrestrial, not emanating from an Earth-based antenna, this does not automatically equate to it being of alien origin. Andrew Siemion, part of the team that detected the signal, added that there is no known natural way to compress electromagnetic energy into a single frequency range as observed in BLC-1. However, he conceded that the signal could potentially be a previously unknown space phenomenon, illustrating our limited understanding of the diversity of cosmic radio waves. The possibility that BLC-1 might stem from an exotic aspect of plasma physics, thus being of natural origin, was also considered. By 2021, the intrigue surrounding BLC-1 had captivated the scientific community for over a year, exemplifying the excitement and complexity inherent in the search for extraterrestrial intelligence. The question of whether the signal BLC-1 was the first alien signal captured by humanity led to a series of further tests, which ultimately yielded a disappointing revelation. Dr. Sheikh, who had previously expressed excitement about the signal, announced that it resembled emissions from electronic devices. The latest research indicated that BLC-1 was likely noise generated by human technology, though the exact source remained unidentified. This revelation was a letdown, but SETI scientists remain dedicated to their daily quest for signals from the cosmos that might hint at extraterrestrial life. The vastness and mystery of the universe are often the starting points for discussions about space exploration. Indeed, the universe is an immense enigma, holding secrets as boundless as its expanse. Viewing the stars offers only a glimpse of what lies beyond our current understanding. However, with scientists and researchers tirelessly working to unravel the universe's numerous mysteries, our collective knowledge is growing incrementally each day. The pursuit of understanding phenomena like dark matter, among many others, continues to be a significant focus in our quest to comprehend the cosmos better. We have a paradoxical understanding of dark matter. We know a great deal about it, yet we know nothing concrete. Dark matter is invisible, but its existence and mass are inferred from gravitational effects on visible matter and radiation. Although we can't see it, scientists believe dark matter has a temperature, which they attempt to estimate by measuring the speed of its particles. The concept of temperature in dark matter is different from how we understand temperature on Earth. Temperature in this context refers to the kinetic energy of dark matter particles. There's a debate about whether dark matter is warm or cold. Its kinetic energy suggests it should be warm, but to exist as observed, it must be cold. So, the exact temperature of dark matter, whether lukewarm, cold, or warm, remains an enigma. Moving to the Sun, its incredibly high temperature is a well-known yet puzzling fact. The core of the Sun reaches about 15 million degrees Celsius. Intriguingly, the Sun becomes cooler as one moves towards its surface, where temperatures are still an intense 4,320 degrees Celsius. The origins and mechanisms of the Sun's immense heat are not fully understood. The Sun's mysteries deepen when considering the temperature of its corona, or halo. This outer layer of the Sun's atmosphere is unexpectedly hotter than the surface below it, defying our basic understanding of heat distribution. These and other cosmic phenomena continue to challenge and fascinate scientists, underscoring the vast and complex nature of our universe. The corona of the Sun, at a staggering 2 million degrees Celsius, is much hotter than its surface, a fact that continues to puzzle scientists. Adding to the Sun's mysteries is the temperature disparity between its poles. The South Pole is cooler than the North Pole, and the reasons for this are yet unknown. In the realm of exoplanet discovery, scientists have found numerous shot Jupiters in nearby star systems. These gas giants are similar to Jupiter in our solar system, but orbit very close to their parent stars. One of the main questions regarding these exoplanets is the origin of the material they are made from. The regions where they are found lack sufficient material to account for their formation, suggesting they must have migrated from more distant parts of their solar systems. However, the exact process and origin of this migration are still mysteries. Botess Void, a vast empty space in the universe, stands in stark contrast to the typical dense packing of celestial bodies. While most galaxies and celestial objects are relatively close to each other and bound by gravitational forces, Botess Void, spanning 330 million light-years, is an anomaly. Despite its size, which could theoretically accommodate around 10,000 galaxies, it remains largely empty. The origins and nature of this void are yet to be explained. Regarding the so-called mysterious alien megastructure, it refers to an unusual pattern of dimming and brightening around the star KIC 8,462,852, also known as Tabby's star. Initially, some speculated this could be due to an alien megastructure, like a Dyson sphere, constructed around the star. However, further research has suggested more natural explanations, such as a cloud of dust or a swarm of comets, though the true nature of these fluctuations remains a topic of ongoing study and debate. The star K, IC 8,462,852, initially suspected to be surrounded by an alien-built sphere due to its unusual flickering, was later found to be orbited by a simple comet cloud. However, this star continues to intrigue NASA researchers and other experts. The mystery lies in its fluctuating luminosity. It has been observed to lose brightness significantly over the years, a phenomenon not aligning with known astrophysical models. This unique behavior, unmatched by any other known celestial body, has led some to speculate about the possibility of an alien civilization's involvement. The Pioneer anomalies, involving the Pioneer 10 and 11 spacecraft launched in 1972 and 1973, also present an unresolved puzzle. These probes unexpectedly deviated from their predicted trajectories by about 386,000 kilometers over 10 billion kilometers traveled. This deviation was not attributable to gravitational forces or solar winds, and nearly half a century later, its cause remains unknown. While there are theories involving dark matter, the exact influence on the probe's trajectories is still a matter of speculation. Beyond the planets of our solar system lies the Kuiper Belt, a vast region teeming with rocky objects. This area, largely unexplored, is known for the decreasing number of Kuiper Belt objects, BBOs, over time, a phenomenon that remains unexplained. The Kuiper Belt represents the threshold beyond which the infinite expanse of space extends, holding countless mysteries yet to be uncovered by human exploration and research. The decreasing number of Kuiper Belt objects, KBOs, over time raises intriguing questions. Contrary to expectations, their numbers should be increasing, not diminishing. One theory suggests this might be due to a large yet undiscovered object or planet in the Kuiper Belt that either repels or attracts these KBOs. The New Horizons probe, currently en route to the Kuiper Belt, is expected to shed more light on this mystery. The uniqueness of Earth in the vast expanse of the universe is a profound mystery. Despite finding planets with Earth-like conditions, none have shown signs of life as we know it with its complex ecosystems, diverse forms of bacteria, and a civilization capable of contemplating its existence. The question of why Earth is so special, hosting life in a way unseen elsewhere, continues to baffle scientists. The search for extraterrestrial life, intelligent or otherwise, is an ongoing endeavor. NASA's space probes and advanced telescopes have explored the solar system and peered billions of light years into space, but have yet to find confirmed evidence of intelligent life. While there have been hints of biological activity, no alien life forms, not even a single microbe, have been definitively identified. Researchers, including amateur astronomers, continue to grapple with the question of whether we are alone in the universe. At the University of Nottingham in England, astrophysicists have used model calculations to estimate the likelihood of extraterrestrial life in our galaxy. Despite the uniqueness of each planet, star, and black hole, certain structures and rhythms, like spheres and spirals, and life cycles, are observed in space. Solar systems are born and eventually perish, and it's speculated that our entire universe is a dynamic system, emerging and eventually ceasing to exist, akin to life forms and civilizations on Earth. Using known algorithms and probabilities, these researchers have calculated the likelihood of other intelligent life forms existing within the Milky Way. Considering the vastness of the known universe, spanning 90 billion light-years and possibly more, the potential for discovering extraterrestrial life remains an open and tantalizing prospect. In the vast expanse of known space, astronomers have identified at least 100 billion galaxies, including our own Milky Way, a spiral arm galaxy. Our solar system resides on an outer spiral of the Milky Way, which spans approximately 100,000 light-years in diameter and hosts between 100 and 400 billion stars. Accompanying these stars are countless planets, moons, and smaller celestial bodies like asteroids and comets. In recent years, researchers have discovered 7 Earth-like exoplanets in close proximity to our solar system. Extending this search further, there could be about 20,000 planets similar to Earth throughout the Milky Way. This extrapolation suggests the possibility of around 300 billion potentially habitable, Earth-like planets across the entire universe. However, the existence of life on these planets remains an unresolved question. The idea of Earth-like exoplanets is grounded in observations, estimations, and model calculations. No one has yet traveled to these distant worlds to verify their conditions. Space probes within our own solar system have shown that scientific model calculations can sometimes be off the mark. Data from Mars, Jupiter, Saturn, and other celestial bodies have often contradicted researchers' assumptions and raised new questions. Thus, model calculations, like those conducted by the University of Nottingham astronomers, must be approached with caution. The goal of the Nottingham study was not just to identify habitable planets, but to calculate the probability of intelligent civilizations. For the purposes of their study, intelligent life was defined as a civilization that has made technological progress and is capable of higher forms of communication, including space research and sending signals into space. These hypothetical life forms are referred to as communicating extraterrestrial intelligent (CETI) entities in the technical realm. This study, despite its speculative nature, provides fascinating insights and discussions about the possibility of intelligent life beyond Earth. The University of Nottingham study on extraterrestrial life was built on several core assumptions. Firstly, it posited that intelligent life requires approximately 4.5 billion years to develop, as it has on Earth. Secondly, the study assumed that a technological civilization, like ours, would last for at least 100 years. Another key factor considered was the metal content of stars and their systems. Metals are crucial for technological progress. Human history shows that the discovery of ice, metals, and alloys was pivotal for technological advancement. The researchers correlated these assumptions with the age of the Milky Way, the history of potential solar system formations, associated exoplanets, and the biological basis of life. Real data and measurements from space telescopes and research stations were used as foundational information. These parameters were synthesized by a computer to estimate a probability. According to their calculations, there could be between 30 and 36 intelligent civilizations in the Milky Way. However, the study, published in July 2020 in the Astrophysical Journal, drew heavy criticism and skepticism from the scientific community. While it generated excitement among alien enthusiasts and the general public, many scientists considered the study's conclusions speculative and not based on concrete facts. Critics found the study overly ambitious and potentially misleading. The researchers at Nottingham defended their work, clarifying that their intention was not to propose an incontrovertible truth, but rather to evolve the cosmic yardstick, termed the astrobiological Copernican frontier. They aimed to use the estimated number of intelligent civilizations in the Milky Way to draw conclusions about the probable continuation of our own civilization. Despite the criticism, the study and its thought model have been deemed interesting and thought-provoking. The feedback from critics provides valuable insights and considerations for future research on the topic of extraterrestrial life and the evolution of civilizations in the cosmos. Europa, one of Jupiter's moons, stands out as one of the brightest celestial bodies in the solar system due to its high albedo of 0.64, meaning it reflects 64% of all incident solar radiation. For comparison, Earth's moon, despite appearing bright in the night sky, has an albedo of just 0.12. Europa's icy surface is marked by reddish colorations and countless furrows, known as linea. These features, which crisscross the moon, are among its most striking optical characteristics. Despite their appearance, these depressions are relatively shallow, and the satellite surface is notably flat. The formation of Europa's complex network of furrows is not fully understood, but theories suggest cryovolcanism or geyser eruptions as possible causes. Europa also features circular and elliptical formations called lenticulae, likely formed by rising warmer ice. Interestingly, Europa has very few impact craters, indicating that its surface is either regularly renewed through natural processes or is geologically young, estimated to be no older than 90 million years. Beneath Europa's icy crust lies a liquid ocean of significant dimensions, though its depth and relationship with the outer ice layer are subjects of debate. While some researchers estimate the ocean's depth at a few miles, others believe it could be as deep as 60 miles. This would imply that Europa harbors twice as much liquid water as Earth, bolstering the possibility of life, as liquid water is a critical component for life as we understand it. Experts theorize that the ocean floor might be rocky, potentially releasing nutrients essential for life. The most compelling evidence for Europa's subsurface ocean comes from NASA's Galileo spacecraft. Between 1995 and 2003, Galileo made 12 flybys of Europa, gathering data that strongly supports the existence of this liquid ocean beneath the icy crust. This discovery continually places Europa at the center of scientific interest regarding the potential for extraterrestrial life. During its mission, the Galileo probe's magnetometer detected a weak magnetic field around Europa, suggesting the presence of an electrically conductive fluid, such as a saltwater ocean, beneath its surface. Additionally, the unique arrangement of linea on Europa might be influenced by the subglacial saltwater ocean, differing from initial scientific expectations. Given Europa's substantial ocean, the question arises, could it support life? Scientists believe that besides liquid water, life requires basic chemical building blocks like carbon, nitrogen, hydrogen, oxygen, and phosphorus. It's likely that these elements were present on Europa at its formation. The Galileo probe also detected layered silicates on Europa's surface, which could have been delivered by a galactic impact. These silicates often contain organic compounds, considered the building blocks of life. The potential for life on Europa extends beyond just the presence of these elements in its ice shell and subterranean ocean. Tidal warming, caused by Jupiter's gravitational pull, could create a dynamic environment where water and nutrients are circulated, further enhancing the potential for life. To understand the possibility of life on Europa, future missions need to analyze its chemical composition in detail. Life forms derive energy through chemical reactions, and since Europa is too far from the sun for photosynthesis, other chemical processes might be the energy source for any potential life. Europa's surface, constantly bombarded by Jupiter's radiation, would likely be inhospitable to life. However, the subterranean ocean could be shielded from this radiation. The radiation that does reach Europa could split water molecules in the moon's atmosphere, potentially leaving behind oxygen. This process raises intriguing possibilities about the chemical environment in Europa's ocean and its suitability for supporting life. If the oxygen generated on Europa's surface can reach the ocean beneath the crust, it could provide a vital chemical energy source for microorganisms. The potential existence of hydrothermal vents on Europa's ocean floor, similar to Earth's deep-sea vents, could also release numerous chemical nutrients essential for the development of life. This parallels theories suggesting that Earth's first life forms originated at such black smokers. While these factors paint a promising picture for the possibility of life on Europa, some aspects indicate a more hostile environment than anticipated. Parts of Europa's surface have been found covered with concentrated sulfuric acid and hydrogen peroxide. This led some researchers to speculate that these corrosive substances might originate from the subglacial ocean, possibly due to intense volcanism, which could also account for the presence of sulfur. Future missions are crucial for providing definitive answers about life on Europa. In the coming years, the European Space Agency, ESA, plans to send the Jupiter Icy Moons Explorer, JUICE, to study the Galilean moons, focusing on the oceans beneath their surfaces. A subsequent mission aims to directly explore Europa's subglacial sea. This ambitious project involves a cryobot spacecraft designed to melt through the moon's thick ice crust and deploy a submarine-like probe into Europa's ocean. These explorations of Europa's icy terrain and subterranean ocean are eagerly anticipated by the scientific community and space enthusiasts alike. What are your thoughts on the enigmatic icy moon Europa? Share your views and join the conversation about this intriguing celestial body. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe. Live Q and a sessions with experts. Your membership will grant you the chance to participate in live Q and a sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.